Now I am going to discuss about the measurement of pressure. So pressure can be measured by using any of these type of instruments. Those are mechanical instruments or electromechanical instruments or electronic instruments. So under mechanical instruments, the instruments which use the mechanical devices, that is means only for the deflection of the pointer it gives the pressure, then it is called mechanical instruments. The examples of mechanical instruments are manometers, Bourdon tubes, etc. And electromechanical instruments means the instruments which use for detection mechanical parts and for indication electrical parts, then these are called electromechanical instruments. And the instruments which use for detection and indication only the electronical instrument devices, so those are called electronic instruments. So as of now we will be discussing about the uh, mm, mechanical instruments. Those are manometers and Bourdon tubes. Coming to the first one, manometer. So here in this manometer will consist of an U-shaped tube here. So this is the U-shaped tube. In this tube there is a liquid filled here. So in this liquid, one side there will be atmospheric pressure and the other side there will be pressure which you need to measure. So because of the pressure, what happens is one side of the liquid there is a more amount of liquid and the other side there is less amount of liquid. So that means there is difference in the levels of the liquid. So this difference in the levels of liquid is nothing but the head. This is called head. So from this head you can measure the pressure by using the formula P is equal to P1 minus P2 is equal to rho GH. So that G is nothing but the gravitational force. H is the head of these two levels, that is H2 minus H1. So from that you can measure the pressure by using the manometer. Next one is the Bourdon tube. This Bourdon tube consists of a C-section here. In this C-section, this is the C-section in which one end is sealed end and the other end through which you can flow the pressure which you need to measure. So this is the sealed end, that is this at this end it is completely closed. And for this sealed end there is adjustable link which is attached. For this adjustable link a pinion is attached here. For this pinion there is a pointer which is is shown on the indicated on the dial shown here. So whenever this is about the construction diagram. Coming to the working principle, when the pressure is which whatever the pressure which you need to measure, that pressure is allowed to flow through this pipe here, through this tube. So when this tube that gas or liquid has entered into this pipe, then what happens is this C section will stretch so because of that stretchiness, then what happens is this adjustable link moves and this moves the pointer. So this pointer will indicate on the scale how much pressure has been applied. So that pressure is nothing but the which you have which you need to measure. The indication is nothing but the pressure which is to be measured. That is the Bourdon tube. Next one is the force transducers. So the transducer which are used to measure the force is nothing but the force transducer. Generally, a force transducer is a sensor that converts input mechanical either load or weight or tension or compression, pressure, whatever might be. So this input mechanical quantity is converted into electrical output signal. So usually the force measure sensors are nothing but the load cells. These are called load cells. Then there are two different types of load cells. Those are cantilever beam type load cell and the other one is column type load cell. So coming to the first one, we shall discuss about the first one, that is the cantilever beam type load cell. So this cantilever beam type load cell consists of a beam here, cantilever beam. In this beam, one end of the beam is connected to the fixed end and the other end is left On this beam, on both sides of the beam you will be attaching strain gauges. So on the upward direction you are attaching the strain gauges 1 3, and in the downward direction strain gauges 2 4 are attached here. So when a force is applied onto the free end of this cantilever beam, so at this end if you apply force, that the force which is to be measured, so that force is applied here on this one end. So at this one end if you apply force, then what happens is this strain gauges 1 3 will have tensile strain. That means it will be expanding. Tensile strain will be there. So as it is expanding, then what happens is the length is increased here. So as the length is increased, resistance increases. Resistance increases. Whereas in the downward strain gauges 2 4 will have compressive strain. That means the resistance will be, the length is decreased, so that the resistance is decreased. So on the one side of the cantilever beam, tensile strain is applied, and on the other side of the cantilever beam, compressive strain is applied. So because of these two strains, if these strain gauges are attached to the Wheatstone bridge, then usually under balance the Wheatstone bridge is, will not show any deflection. That means there is no force applied. Whenever there is a deflection, that means the bridge is unbalanced, and the deflection of that Wheatstone bridge will show the how much force has been applied. Usually the applications, these cantilever beam type cells are used in low weight, low force measurement. That means in case of money counting machines, likewise wherever the force which is very small, so in those you can use this cantilever beam type load cell. And next one is the column type load cell. This column type load cell is will have a cylindrical steel cylinder which is having strain gauges on the cylinder here. So in these strain gauges are allowed such that two strain gauges, one in the front one and the other one in the back one, these are placed along the axis direction, and two strain gauges are placed along the circumferential direction. So that means whenever you apply load on this cylinder, so in this way or in this way, then what happens is the strain gauges will have tension or compression, will experience tension or compression. Because of the tension or compression, what happens is the strain gauges will have resistance change. So that resistance change can be measured by using the Wheatstone bridge. These four strain gauges can be connected to the four arms of the Wheatstone bridge. Whenever the load is not connected, the bridge is balanced and there will not be any deflection. So when there is load applied, then when there is force applied, then what happens is there is a tension or compression, compressive strain. Because of that the resistance changes, and because of that resistance changes there is a deflection in the Wheatstone bridge, and that deflection will show the force which is to be measured, indicate the force which is to be measured. This is about the force measurement. So force measurement can be done by using the load cells, and the different types of load cells are nothing but cantilever beam type load cell and column type load cell.